Okay, I think this is worthy of a documentary here in trying to see if the 24 3/4 inch stainless steel had any, trying to get that anomalous effect back that I had in the 15-inch mild steel. And I started messing with the swirl device inside, and I found out that if you choke out the swirl device by wrapping wire or putting copper in there, it just causes it to go into an unbalanced state. It doesn't run smooth. So the jet has to be, or the orifice has to be right for the size of the pipe. Just like in a car engine. In a, you have to have the right size of jet or your engine's not going to run smooth, right? Same way. So in trying to, figuring with that, messing around with that, and I thought, well, what would happen if you took the swirl device here and position it at the 15-inch mark. And the reason for that was to try to replicate the 15-inch steel test where I had that anomalous frame front. Not sure what I'm going to call it yet. Probably like an ultra high level 2, because it actually was going into a transition point here, like a level 1 into a level 2, but it was up a scale, so we can call it the ultra scale. So like an ultra level 1, level 1 going into a level 2, so ultra 2. Low, so it'd be L, L2U, ultra, or that would be level flame, or level 2 flame, ultra, at the ultra mark. So we'll call it that. By being able to take the swirl device and position it in the pipe, and to where you can actually adjust the characteristics of the Joe pipe. This is a big find. That means now it's going to open up a whole new paradigm of testing. But the big find today was where the L2 flame, the ultra level 2 that we seen in the 15-inch mild steel, was brought back into this position here to produce an ultra high level 3. I don't know if it's a level 3 or a level 4. And what was I say, level 4, ultra high level 4. That would be L4U. And I've had the hottest heats ever done in 4 years of Joe pipe testing, except where the Joe pipe has went anomalous, where I've seen stainless steel, copper, and titanium go superconductive. What I mean by that, it goes to its boiling point of the metal without melting, still being in solid phase. I've seen copper melt titanium, and in the books that's not possible, but I have the results. I have the pieces. So eventually what I'd like to do is I may get some plaster of Paris and design a this rocket stove. It's going to be between a rocket stove and a gasification stove, side feed or top feed, and it's going to be 3 stages. The bottom will be a combustible, probably a hexagonal design to give you a nice base, and on the top would be the top would have a hole in it, maybe 1.5 inches, 2 inch. And that's where your wood smoke would come up. Go into a cyclonic spinner, and the spinner would be divided into a lower half and the top half. So as the heat's coming up, it would be dispersed out toward the side and come back into the top portion where you would inject your air, and that would cause an updraft in the bottom of the gasifier. Then on top of your spinner you would have your, like a, if you had this pipe here, and if you had this encased with crucible here, that would be your tower that added to the top of your cyclone generator. And so you should be able to generate lots of wood gas, and as it goes up into the spinner it'll be mixed with air, and it'll be superheating as it does. It'll be going through there, just all the heavy particles will be burning up as they're spun toward the outside. Then it'll go from a centrifugal spin to a centripetal spin as it enters into the Joe pipe. And if we can actually duplicate even a normal level 3 or level 4 inside the Joe pipe, there's not going to be no trace of carbon. Like, all your carbons are going to be gone, as far as your oils and things like that from wood. Everything should be cracked. You're looking at temperatures right now with it right here, just with this stainless and the ultra level 4 or level 2 or 3 inside there. It must be all of 2300, because I've never seen it openly melt copper and melt steel like it did here. And if that was insulated, it definitely is going to make for a very nice kiln. I think soapstone will probably absorb more heat than this, but this has stood the test. It didn't blow apart, and we did reach yellow point on the castable. The steel is actually melted right into the castable, and you can see in there, that's what's left of the brass and the copper, and just turned that in no time into liquid. And the purpose for this new kind of bio rocket stove, using the natural convection spin, centripetal spin, is to crack any and all tar within the wood gas, and to where it's superheated a few hundred degrees or so above the cracking point of the tars, and then you can use the cold air to cool it down to where it's usable. And so you would have a confined source or a closed system of superheated air, and you'd be able to heat up any kind of an enclosed system. If you had, say, if you had an attaché case, or things you walk around with, if that was made out of stainless and insulated, with the top being stainless for cooking, that should heat it up to cooking within about 30 seconds. Or you could turn a handle, then you could actually port the superheated exhaust into your oven, and you can control it by adding outside air. So you would have an oven, or you could use it to heat water, or you could use it to make steam, or you could use it as a space heater, just from the super hot, creating a source of super generated hot air. It's that simple. You don't need an open flame. You'll make a nice gasification system that puts out the clean exhaust, and it's going to give you allow you to do anything that you want to do. With the normal rocket stove, all it does is cook, and you're still getting the exhaust in the room. And this way you can actually have the heat do the work for you, do much more than just make a pot of coffee or dinner. You can have a pizza oven if you wanted to, or you could take the super hot air and wrap it around a plenum to make hundreds of gallons of hot water, all kinds of stuff. Anyway, this brings this test to a close today. I'm going to stop here. I may do some testing tonight using the same system, and I'd like to see if we can get the pulse back. Okay, that's it.